The battery has become optional. Electromechanical ideal blocking diode, 100% PV to load operation mode. Off the electrical grid in the 1900s. I've been researching and building an off-grid pure DC system that does not use a charge controller or an inverter. It can now leverage commercial off-the-shelf batteries and solar to power a variety of appliances straight from the wall using DC. The system can even run directly off of PV-DC solar panels without the battery. The focus of my research has always been doing something new and testing the boundaries of what solar can actually do. Hello friends and subscribers, Dave here. Thanks for tuning in. In part 1, I introduced a novel 55 volts DC residential off-grid system that needs no charge controller or inverter to function. I'll link that part 1 introduction video here and in the description. That system was under testing and development for several years before I made that video, but it was always in experimental form and never felt like a proper standardized system. In part 2, it's time to take this technology live. Over the past several months, I have been working to install DC cables, load centers, and outlets inside the house at my new homestead. Other buildings will also be tied into this system, forming a DC microgrid. Of course, running cables isn't fun, and I ran into a lot of mishaps, such as falling on an icy deck and injuring my knees, hip, face, and shoulder. But in spite of all these issues, progress moves forward. Today I'm going to show you the first officially installed version of my residential 55 volts DC microgrid with load center and explain how it works. So here's my PV to load DC load center, still under construction but in live operation and feeding circuits in my house already. Think of this DC load center as the equivalent of the AC load center in an average house today. Except it's not fed by the utility power company. Instead, it's fed by my own renewable DC solar power coming straight from the solar arrays. It primarily funnels direct PV-DC power straight from the solar arrays and into various domestic household loads and appliances. It also ties multiple buildings together to form a DC microgrid, and these grid nodes then can team up and support each other. It integrates backup batteries to ensure DC microgrid voltage stability and power availability during cloudy conditions and nighttime operations. Inside this box is the main DC bus for this house at this time. The max service rating at this time is 150 amps. Of course, I'm going to upgrade it. My goal is to reach the 200 to 400 amp service level per building in order to power larger loads such as my electric dryer and other larger machines. The photovoltaic DC power enters the bus first through multiple cable sets, circuit breakers, and fuses. It then transits through an electromechanical ideal blocking diode, or EIBD. This is a Schottky type diode with a low voltage drop. When photovoltaic DC current feeding the system exceeds around 5 amps, the diode is simply shorted out of circuit by a DC contactor. This further improves efficiency and reduces power losses through the diode, especially with current flows at over 50 amps. The PV solar panels I'm using were specifically chosen to have a nominal max power operating voltage matching the nominal operating voltage of 16S lithium iron phosphate battery modules. This is exactly the same kind of technology that my mini 18-volt Powerwall that I showed in a previous video used. This kind of design means the battery can charge as needed, but with zero DC conversion, through protective systems, of course. This is yet another efficiency gain, and no charge controller is needed, and one less thing to break and buy a new one of every few years. And no, the system will not overcharge the battery, and it's perfectly safe. In fact, the battery is deliberately kept in a state of no more than 80 to 90% state of charge. The purpose of this contactor is to close the circuit between the battery and PV-DC service bus, but only if the bus voltage falls outside of the proper range. Ideally, it should not drop below about 50 volts DC, or appliances might not run as well or even stop working altogether. This function is not a charge controller per se. Its purpose is to monitor the PV-DC bus and microgrid voltage and ensure it never falls below the specified value. If the battery happens to be taking a charge at that time, when it reaches the voltage level I have set, it is simply disconnected and put into standby. The PV-DC bus voltage will then float upwards naturally and enter 100% PV to load operation mode. I'm amazed at the power and simplicity of this off-grid system. It bypasses the need for an inverter and charge controller, and yet can easily operate alongside a traditional off-grid system if needed. Even if for some reason my battery were to fail, I would still be able to operate as long as the sun was shining, and all my appliances would continue functioning. In fact, some of the footage you see in this video was done with direct PV power. There was no battery connected. The system operates both ways. This is the DC load center that I'm building, ironically right next to my AC load center. Currently I'm running all of the copper cabling, and there's going to be a lot of breakers. This is going to feed the outlets in the house. If you want to see what one of the circuits looks like, well, there it is. There's not much to look at. It's just an outlet box on the wall. So I chose this outlet because it was possible to get them for not too much money. They don't fit any of my AC appliances, so there's hopefully no risk of somebody coming in here and trying to plug an AC appliance in. Don't want any extra trouble. This circuit here is a 15 amp circuit. I have others that are 20, and I'm going to have some that are 100, 200 for running big loads. But most of my circuits only need to be around 15 amps. All of those circuits will be fed from this, and that will tie into the integration system here, which controls the voltage of the PV bus. It controls whether or not the battery's connected. It has safety fusing in it. Lots of stuff that, unfortunately, due to financial and physical constraints, you just have to take it one step at a time. I just keep ordering breakers when I have the money. This breaker box was just installed, and hopefully I'll have that done in the next few weeks. This is not the only solar coming in the property. This is just this end of the house. This is the kitchen and utility room area. I'm going to show you how we use this system with pure DC straight from the solar panels to bake, cook, boil, run lights. So all of the power coming into this system is direct photovoltaic DC straight from the solar panels into the system and into the outlets. And it actually integrates a 16S lithium iron phosphate battery. And that's why all the extra safety and extra breakers and fuses are necessary. This is kind of a edge case. This is not something people would normally do. Even running directly off of PV is not something people would normally do. So the battery isn't necessarily going to be connected to the PV-DC bus. It may or it may not. It depends on the voltage, it depends on the load, the conditions, and whether it's nighttime, because at nighttime, this system will switch the battery in to keep things running. So the battery is actually optional. This is the first time in off-grid solar that the battery has become optional. This is a new concept. I've not seen anyone do it this way. There is no charge controller, there's no inverter, there's no DC conversion required, and this is using voltage matched systems. So the battery, the solar panels, and the loads are voltage matched. Believe it or not, there were many homes off the electrical grid in the 1900s, even while the so-called power grid we know today was getting its start. A typical solution was a wind generator or some kind of gasoline-powered generator, along with a rack of lead-acid batteries, typically arranged in a voltage of 36 volts. Kohler and Delco were two of the more well-known companies that sold these gasoline-powered lighting solutions to the general public. Obviously, a system like this did not provide as much power as an actual grid hookup, but it was better than working on your farm in the dark. A typical system might put out several hundred watts and be able to light over a dozen 50-watt light bulbs, or it might be running fewer bulbs but also powering some electric appliances. I remember reading a comment from a gentleman who told me that back in those days they actually had appliances in different versions, including the farm version, and the farm version was actually a DC-powered electric version designed for running off the electrical grid. The greatest blessing of these systems was that you no longer had to worry about kerosene lanterns and fire risks. You could just turn on an electric light bulb and be done with it. These off-grid systems actually did quite a bit more than run lights and small appliances. They could also pump water and do many other things. Unfortunately, I could not find any photographs of the early lead-acid batteries that were in use. They were like glass jars, and they were arranged in banks of several, 2 volts each, usually in wooden boxes and lined up against a wall and shelves. Each battery gave about 1 or 2 volts, and when connected in series, they gave well over 30 volts DC. I find it amusing that the Delco sales representatives in those days had a Delco power generator system in their cars. And when they traveled to the farms to try to sell their system, they would turn on lights and brew coffee and use that to try to sell their system. And yes, they had electric coffee brewers in those days that were powered by DC. This system is still under construction, but it really needs a battery, and that's what these large, thick copper cables are for. I cannot afford the type of battery that would power a system like this. Several months ago, a company called Power Queen, which I had worked with before, contacted me and wanted to send me one of their batteries to evaluate in this system. I did not agree to accept any payment or anything like that, but I will test it in the system and tell you what I think about it. Some years ago, I made a video about pure DC cooking using 12 volts, no inverter, and no charge controller. That video was incomplete and I never got to finish it. However, it was the first collaboration I ever did with Power Queen in which I tested their 12 volts 200 amp hour battery. And that battery performed very, very well. Although it wasn't shown in this video, many of the concepts and technologies that are being developed for this 55 volts DC system were being tested behind the scenes and were powering this 12 volt DC cooking system. You know, I'm not trying to sway you one way or the other. But if it's a good battery, I'll tell you. And if there's anything negative, I will tell you that as well. Hopefully it just works. So this battery is going to give us about 5 kilowatt hours of storage. I don't charge lithium iron phosphate to 100% normally, so we could call it 4 to 4.5 under ordinary conditions. Let's get this thing hooked up. It's currently nighttime and there's no solar. The system has transitioned to night mode. It's running purely on the battery right now, still DC. It's powering all of our circuits. And you can see we're only pulling about 475 watts at this very moment. We just turned on this cooktop here and we're making some hot water for the dishes. Again, that's running on battery right now because it is nighttime outside. Of course, we also have a variety of lamps and lights that run on the system as well. And we use those at night to keep the lights on. And that's one of these space heaters I haven't finished converting yet that's running on the system as well. It's now morning and the system is getting a little bit of solar, but most of the power is going to come from the battery. Everything will continue functioning as normal, including the cooktops, any heaters or lights, or any other devices. Well, DC is taking over the kitchen here. Past several weeks we've used almost no AC power to do our cooking. It's all been DC. And this oven here still gets a little bit of use, but most of the time we're using the DC now. This oven has not been converted yet. Cooking the roast on the induction cooktop. And this is just a standard modified resistance cooktop. Not very fancy, but it works. Cooking some potatoes there. We're also using the kettle to make some hot water. It's hard to describe how effective this system is. It just works. It's clean, it's simple. There's no switching noise or AC, and there's not much I can say except it just works. It works far better than I thought it would. I've been working on something like this for several years now. I just didn't have the wherewithal and means to get it done. The kitchen kind of took priority. I did have outlets in other parts of the house, but the kitchen was high priority for me. I really wanted to get that running on DC. I'm still working on installing the rest of the infrastructure. It's just a really, really big project. It cannot be done overnight. My health has not been good. That's really slowed me down big time. We're using this every single day now. Let's see what we're pulling at this very moment. 720 something watts. However, that's not counting the solar power, so it's probably way over a kilowatt. And we're using the Power Queen battery monitor here. This thing has been working very well. Of course, I'm also running my prototype space heater here, which is unfinished. And I will make a video about it when it's done. Because when it's not done, I don't want to show things that are unsafe. There are 3 or 4 other space heaters in other parts of the house that are also powered by the same system. I just love this simple system that just uses the DC straight from the solar panels. What can get better than that? Wonderful. It's grid down friendly, it's robust, it doesn't have a ton of electronics, if any. Even parts of the system that have electronics, if they were to fail, this system will keep running. Induction cooktop, yeah, that might fail. That's just a simple resistance heating element. Of course, they require modification. It's not necessarily safe, but there's no reason whatsoever why simple kitchen-grade DC cooktops can't exist. Just because factories aren't making them doesn't mean they can't. I really believe these will be everywhere, and you'll be able to plug them straight into your 51.2 volt lithium battery system, and off you go. I'm also building multiple ovens. This is one of my more recent models. It's not finished. and so I decided not to show a lot of information about it in this video, but I have two of these ovens. One of them is a multi-voltage 12 volts, 24 volts, and 55 volts capable oven. This is going to be the simplest one, and then the other one is going to be way more advanced, and it's deserving of its own video by far. If you want to try building your own DC ovens, have a look at my 12 volt DC oven build video, which is extensive and detailed. I'll put a link to that in the description. Well, it'll be time to eat soon. This is the most power I've ever used in the kitchen. We're running 3 appliances today. I started with 1, worked my way up to 2, and now I'm doing 3, and probably going to add 3 more outlets. It's several weeks later, and the DC system has had heavy use 24/7 around the clock, especially in the kitchen. And the 55 volts DC system has been working perfectly. I've not had a single problem with it. Today we're cooking some vegetables on the induction cooktop. The system is still working well. This is several weeks later. I haven't had any problems with it at all. One amazing thing about it is that it's quiet. There's no fan noise. There's no real heat generated. It just runs, it works. So I must say this has to be the future in some form. This works so well. I don't know exactly what the future will look like, but it will definitely involve DC. You can count on that. And just to be clear, I'm not against inverters, charge controllers, and so forth. You can see I'm running MPPTs right there on my traditional 12 volt system, but when I compare the DC to this is in another level. And the DC has several different advantages and cost benefits. Many of the components that are in that box are just very simple devices. They're not sensitive to electrostatic discharge or anything like that. My desire is not to influence you, but rather to inform and share my expertise and let you think for yourself. We've been running this Power Queen battery for several weeks now, 24/7, 365, but I have to say that it's working just fine. Sometimes solar just works, and this is one of those cases. The best kind of test is a long-term test, and that's what we're going to be doing over the next several months. If you wish to buy this battery, there's a discount in the description as well as a link, but I don't make money from that link. Again, I wish to thank Power Queen for sending me this sample battery for this project, without which it would not be possible. Hopefully, this battery will continue to serve us for many years to come. We'll see. If you liked this video and you want to support my work, please thumbs up, comment, and subscribe. Thanks for watching, folks, and I'll see you next time.